We now have Patricia Conder, who I think is happy to be called Trish.
Yes.
There you go, with a paper, Non-Destructive Testing Challenges in a Net Zero World. So Trish is Principal Consultant, Inspection and NDT Consultancy at ESR Technology Limited. Trish has a multifaceted background, having worked in a range of sectors, including electronics, chemicals, pulp and paper, before entering the inspection and non-destructive testing field. 3 years ago, she joined ESR as Principal Consultant in their inspection and NDT team. She has worked on a range of projects for both HOIS, the energy sector-focused joint industry project with ESR, and directly for clients. HOIS's focus of advancing NDT for in-service inspection has enabled Patricia to work on a range of projects. Patricia has an honours degree in physics from the University of Aberdeen and a PhD in materials science from the University of Birmingham.
So I'd just like to introduce HOIS, who we are, what we do. As I said, we're a joint industry project, and our vision is to be the best forum for the energy industry to improve effectiveness of in-service non-destructive testing. We came from a pedigree of the oil and gas industry, but like everybody else, we're expanding our horizons and looking at energy, the energy sector. And we've got a number of energy operators, and we've got a number of supply companies, and the HSE is also a member from a regulatory point of view. And the program's chosen by the membership, so we're driven by the membership what their key challenges are at the moment. And if you have a little look at the list of ongoing projects, you know, a lot of them look, I suppose, a bit oil and gas-like, but it's really to do with looking at focusing on the challenges of a particular component or a particular type of corrosion, be that external corrosion, be that under pipe supports from that point of view, looking at issues at elevated temperatures. But the common theme is that we're presented with a problem, we can go out there and look at the non-destructive, the best non-destructive practice to test whatever you're looking for. So it doesn't really matter if that's coming from a metals point of view, composites point of view. It's always the same approach. We run blind trials that support validation. We also have a sort of desk-based review program looking at other things. And a couple of the topics that we're looking at are digitalization of NDT. How does that impact on our world? Low carbon and emissions reduction, and human factors as well. How does the human factors tie in? So that's sort of a little bit about HOIS, but where does net zero fit in? Or where does NDT fit into net zero? And we've been hearing all day about all this rapid engineering and materials advances. Everything's changing so quickly. And really, unfortunately for us, inspection picks up degradation. We're always looking for the lagging indicator. It's always already happened before we come to it. So it's the role of inspection to sort of predict maintenance requirements and to reduce that risk of failure. If you didn't think things were going to degrade, I'd be out of a job. Nobody would be wanting to inspect anything. So that would be great. I'll put my feet up. You know, are there new challenges out there? Is it just the same old, we've already got all the techniques we need? Or are you going to come up with new challenges, new degradation mechanisms that we need to be sort of, to keep up this rate of rapid advancement? You know, what do we need to know? What's the critical flow size in that hydrogen pipeline? Can we actually detect it? So I'm here to sort of pose a set of questions, not necessarily give you a set of answers, but it just sort of to flag up that, yes, after you've got all the equipment in, we might need to do some inspection. So this afternoon, I'd just like to talk about what are called the 5 facets of NDT, and I'll give you some examples as we go about these facets. And the first up is the degradation mechanism. What are you actually looking for? If you don't define what you're looking for, NDT is not going to necessarily, we can only see what we're looking for. If you're looking for a crack and we go looking for our general wall loss, it's not going to cut the mustard. We're not going to see it. So you need to know in advance, what are you actually looking for? The actual physics of it, how can you find it? Are you doing visual? Are you doing ultrasound? Are you doing electromagnetic? And how are you actually, the inspection deployment, how are you going to get your inspection equipment to the location of interest? Be that manual, be that robotics, be that drones, as we saw this morning. And how are you actually perhaps going to scan, or are you going to monitor? So there's all that aspects. And then there's the aspect of planning, where, how much, and when. My esteemed speaker from BP this morning was talking about this change when you're looking at carbon capture and storage from a regime where you've got degradation that's sort of happening all the time in a predictive manner, and you can go in and you can inspect and you can sort of say, well, this is the corrosion rate and this is the degradation. And then you're going to a regime where it's nothing happening, and then you've got a massive excursion. You know, how do you deal with that? So there's that aspect. And then after you've collected all this inspection data, what can you do with it? So that's my takeaways. I can give up now. So I'll just give some examples. As I was saying, with degradation, you really need to know what you're looking for. It's a lagging indicator, and you're coming up with different materials, different composites, different materials that can have different degradation mechanisms. There's different manufacturing routes being used. For example, additive manufacturing, and hoisted a member document on the different degradation mechanisms that can be associated with that. And as we've seen, you can have different applications of the same materials. If you're repurposing pipelines, then, you know, as Daniel was talking about, you can run into hydrogen embrittlement. So, you know, you need to define the degradation mechanism that you're looking for. We've done a couple of pieces of work really on an information exchange, because everything's happening so rapidly that we're not saying this is a definitive. We're saying, actually, you know, Rosen have done this work, go and look at this piece. So it's an information flow that we've done for members. So by all means, if you know other pieces of information. And it's just highlighting, trying to highlight to the NDT community some of the challenges that are going to come up. What is the critical flaw size that will be looked at? Is there a gap in that dialogue between all the materials people saying it's going to be this critical flaw size, and all the inspection companies going, you know, really? You really want us to find that? And at what probability of detection? So there has to be that dialogue between the two sides. We're sort of waiting for all this information to come at us. So it's an education of that NDT community. And as I said, the second facet of it all is the physics of inspection. How do you physically get a signal from your degradation mechanism? Be that visually, are you just going to look at it? Do you need an ultrasound to put in a sound wave into the material and get a response back? Various electromagnetic techniques. It really depends on your material and that you're looking at, and that degradation mechanism. And there's other aspects. You know, the actual geometry of the equipment. You might say, well, yes, I can use UT on X52 metal, but then, well, actually, I'm interested in the flange face corrosion. So it's down to the geometry and looking at how you're actually putting that sound wave in and getting a response back. So there's a number of factors that play into the physics of the inspection, including the different materials, but also things like coatings. Some coatings are absolutely fabulous, and then the ultrasound signals go through them really well. Other coatings, very attenuating. You know, if you want to inspect, please don't put them on. So it's thinking about all these different aspects, and as I said, the different geometries. Picking up on a speaker this morning, talking about categorizing the defects on the leading edge blade of wind turbines, or inspecting plants for exterior corrosion. Very much the flavor of the month is aerial, UAV, either video or still photography. And one of the things we've looked at in the past is saying, well, that's lovely, but are you able to see your defect of interest, your category of defect on your leading edge blade? Will essentially the visual actually deliver what you're looking for? And one of the guidance documents we put in was looking at those aspects, and looking at essentially one of the outcomes was a recommendation that you actually photograph a line pair, a grid, a resolution chart, so you can sort of say, well, yes, I was at this standoff, I could see at this definition. And that's been taken up by some of the ASME regulations. So it's just, from our point of view, it's yes, are you delivering that difference between your Cat 1, Cat 2 thing, and do you have that confidence in that? Inspection deployment, yes. Are you going to manage to get to your chosen locations of what you're looking at? Are you going to get the rate and extent of coverage? And you've got this choice between monitoring or periodic inspection. And I know certainly brand new wind turbines, they're great from the point of view you can put in a lot of fixed monitors, and you can correlate different mechanisms from the degradation in the gear systems to other things. And that's great as long as you're either monitoring the whole component, which is fine if you're doing things like acoustic emission or vibration, or whether a sort of restricted location sampling is actually a valid representation of what you're looking for. And that's an issue sometimes with the pipelines and piping. Have you got enough sampling to give you that idea? And of course, I mean, the defaults on all NDT is to do it manually, get your probe, put it on whatever component. But there's a whole range of different sort of semi-autonomous and autonomous robotic and other delivery forms. And they might look very different, but potentially you can do ultrasonics from a UAV. So potentially all these subsea, ILI, aerial scanning, they're all delivering essentially potentially the same physics in terms of NDT, but they're just doing it in very different ways for very different challenges. This is another example of how hoists have contributed to this sort of deployment area. And hot off the presses, because it was just released about a week ago, was our recommended practice for remote internal inspection. And this is for pressure vessels, but it very much follows the structure for, we've done a similar one for external inspection of pressure vessels. But again, this can be translated to any large-scale inspection challenge, and saying, how do we make sure that inspections are equal? If you're coming from different inspection companies, are you going to get the same upfront structure in planning the inspection, delivering the quality of inspection, choosing the inspection techniques so that you get what you want? And again, I mean, I keep thinking about the wind turbines with the visual inspection, with the internal visual when you're looking for degradation. You need to think about the aspects such as the color resolution of your cameras, and the color definition, and your lighting, because the angle of the lighting can have a huge impact. And again, you know, any exterior structures, it's not necessary. On some days you could get the resolution, but if you've got the sun in the wrong place, or you can get very different actual outputs. And you just need to be aware of all these factors. So this is an example where we're having, you know, giving you a structure to think about. And the barriers, it was trying to have a collective industry breakdown of the barriers to adopting this sort of methodology, because there isn't necessarily a sufficient understanding of all the technologies and capabilities that are out there. So there it is. It has been done in conjunction with the Sprint Robotics sort of JIP, who are dealing with the delivery, the deployment aspects. We're looking at the aspects of planning and making sure your NDT or your visual is actually coming up to standard and delivering the probability of detection that you'd expect it to. And the HSE also have a program looking at this, so we're trying to all be complementary and aligned in that case. And I know the HSE are about to bring out a report looking at the consistency of visual reporting as well. So that comes to my next point. It's planning. You know, where are you going to inspect? When are you going to inspect? How much are you going to inspect? As I said, is monitoring an option? Monitoring, you know, it gets you've got equipment there all the time. It's not moving around. You can get that precision, but is it representative? Can you do the whole component, which is great, or are you at the right location to be representative? And you need to understand, to get on this, when do you inspect, the likelihood of your degradation mechanisms occurring, how they progress. Is it a nice, even, sort of, we're expecting a linear corrosion rate, that everybody does 2 points and draws a straight line in between, or are you in the carbon capture, the CO2 regime, where everything's fabulous until you have an excursion, which can change your view of your integrity management. You know, you've had this pipeline, it's had its interval of inspection, and then you come into a totally different regime. So that throws things in as well. And the spatial distribution of degradation. I know, I don't want to talk about corrosion engineering, you know, it's either general or it's localized. Well, actually, there's quite a lot in between when you're talking about efficiencies of inspection as well. Another example, we have looked at, we've tried to pose these questions, you know, where's the challenges going to come? So we have done a landscaping study on offshore wind farms. So not just looking at the blades, looking at everything, looking at the subsea structures, and is there challenges in there as well? And with everything, you know, there's a drive for cost-effective inspection to minimize the maintenance intervention, but also to minimize the inspection costs. So it's the right inspection at the right time to make the right decisions. And some of the, is this the same photo as everybody else has been throwing up? You know, you've seen, yes, some of the damage mechanisms are just totally unique to that application. You know, nobody with a subsurface pipeline is going to be worrying about lightning strikes and leading edge corrosion and erosion, sorry. But then there's other mechanisms that are common to other marine structures, microbial induced influence corrosion, hydrogen induced cracking. You know, there is a lot of commonality. So it's really a case of, well, do we already have the equipment and the knowledge to deal with these, or does there need to be some advances in this? And as I was saying, you know, there are some, as somebody was telling me, well, there's not always, but there's some excellent examples of monitoring of offshore wind where you're using the inspection data collectively and not using it in isolation. So you have different monitoring techniques to look at different things, and you're doing a time series-based analysis of that. And from the NDT point of view, there's a range of monitoring examples, acoustic emission, because you can put on a few listening devices and you can hear a whole component, and other vibrational analysis and other ones. And as I said, time-based linking. And it just goes into a bit more detail, we're thinking about, as I said, the type of inspection. Should you be doing monitoring? Can you do periodic inspection? So it's just bringing up all these different aspects and different challenges. We've been talking about blades, but there's the floating substructure, there's the cabling to keep it. Each component has its own degradation challenges, and which one comes top of the list in terms of keeping them maintained and up there. So I suppose my latter point, I better slow down rather than speeding up, is data analytics. What does it all mean? Very much, from my perspective, historic non-destructive testing data has very much been focused on reporting this on the area of inspection, recording a minimum wall thickness, a category of corrosion, has the anomaly exceeded a threshold. But the focus has really shifted to looking at the bigger picture and trying to combine results and see and do that learning from one component to the whole. I work a lot in piping, but it's just, yes, if you've got learning from one wind farm, can you take it to another wind farm? Can you see that bigger picture and get your prediction improved so that you can go through that cycle of say, when do we need to look, what do we need to look for? And it all feeds back into that. And it builds on a lot of statistics, but also, like everybody else, we're into machine learning and AI, and it's really understanding where that comes from. And certainly, I'm not sure what's on the next slide, one of the sort of expanding areas of this is very much visual inspection, because you can get a lot of video footage, a lot of stills photography very quickly, and it can take a long time for somebody to sit there and plow their way through it. But equally, you've got a huge learning data set to do your learning from, so that it lends itself very well to machine learning, and you can get assisted degradation recognition, where you can get the computer to plow the way through and say, actually, you want to look at this area, you want to look at this area, you want to look at this area. And it's been very much an expanding area. I mean, especially, I suppose, in the field I've been looking at for external corrosion of equipment, very much you can look at it, you can categorize it, and then the next time round at the next inspection is very, it's very detailed. It can say, has this area progressed, has it not progressed, and help you prioritize things. So certainly visual data very much lends itself to the use of AI. So we've been looking at that sort of thing. And as I said, developing this understanding of the likelihood, the progression, and the spatial nature, especially because, the larger the components, you're probably actually wanting to do less inspection. And although, I'll try there, one of our older reports is on the statistics, actually, of NDT inspection. And this has sort of led, it's got a sort of little family tree of reports. It led initially onto our recommended practice for NII pressure vessels, but this sort of idea of really tying together the spatial distribution. What are you expecting to see? Do you expect to see your degradation everywhere, and you can inspect a little amount and get a good understanding of what's going on? Or are you in the situation where you might have a coated vessel, and when the coating breaks down, it's in an unpredictable area, and you're actually looking at more towards 100% inspection? Or are you somewhere in between where you want to categorize it? And this very much idea of trying to sort of pin together the degradation and the extent of the degradation with your inspection planning, and then ultimately looking at it and saying, well, if I'd inspected it all, what would it get to? So one of the things we run in this sort of digitalization space is a forum that runs about 6 times a year, and it's open to absolutely anybody. You can all sign up and come along. And there's usually about 3 speakers, and they're speaking about all different aspects of digitalization in the NDT space, whether it be, as I sort of talked about, this is an example. Oops, sorry. This is an example of visual use, machine learning visual use of data to categorize external corrosion. But this could equally methodology be applied to wind turbine blades or anything where you're collecting large amounts of visual data. So a whole range of different topics, and as I said, it's running. So that's just sort of as our role as information exchange from that point of view. So that sort of brings me full circle back to my 5 points. New applications, new challenges, same approach, different approach. And what we're looking for is you to say, you know, what are you actually looking for? Are you looking for a fine pit? Are you looking for a big area of corrosion? Different challenge. How can you find it? There's more inspection techniques than you can shake your hat at. There's a vast range. There's always room for more, but there can be transferable between industries. Somebody was talking about, you know, inspecting through concrete. Yes, it's all transferable. It's all the same physics. How do you access your chosen locations? That's coming down to the robotics. How, when, and where, planning, and you know, you've spent a lot of money collecting this inspection data. How are you actually going to leverage that value? Thinking about the next time round. So my sort of takeaway message is NDT inspection solutions can only meet defined challenges, and the better the definition of the degradation, the better the inspection solutions will be. Thanks very much. He's got too many switches.
Yeah. Any questions for Trish?
Stuart Bond from AM. Patricia, thank you for that. You alluded briefly to the probability of detection for a flaw. And I just wondered, in the context of Daniel's presentation and the reuse of pipelines for hydrogen service, if we find through our engineering critical assessments that we've got a critical flaw size that's very small, presumably that's either a challenge because you can't find it, or it's a significant challenge if in weldments, which are built to current construction standards, the flaws there are larger. So is that going to be a showstopper?
I think it needs communication. It could be a showstopper, and that could drive your choice to replace that section of pipeline. And that's where there needs to be communication, because I know there's a DNV joint industry project doing a lot of work on the materials testing and sort of saying what is the critical flaw size. And then there's my colleague Daniel saying, well, you know, that's the critical flaw size. What POD do you want? Do you want to see every single flaw? That is a major challenge, and it will be. And this is where I'm saying we need a bit of lead time. Everything's happening so fast. If you want to meet all these deadlines, you're going to have to try and communicate up front what the challenges are going to be to get that head start.